All right, so I'm looking at it, and I realize that that this thing would be identical to this one over here, n equals 2 to infinity. Now someone says, why are you starting at 2 now and you're not starting at 1? Well, at 1, that first term would be 0, because the natural log of 1, right this over here, is equal to 0. So I know the first term's 0, so I'm going to start at 2 instead. Get the eraser over here. So let me write this one over here, and this is going to be n, ln n. This looks really difficult, by the way, n plus 1 cubed. So what I want to do is I want to, sort of like get a comparison for it. And the comparison I'm looking at, and it's really tough though, but I'm looking at n, ln n, and then I'm looking at the bottom, which is n plus 1 cubed. And I want to go in stages for this one over here. And the stage I want to look at is I want to look at, the top's really tough, by the way. The bottom, I can make this comparison over here. All right? Now, certainly for 2 forward, it's a positive term series. So that's not my issue over here. And my first issue is, how do these things compare? Which one's larger? Well, the tops are identical. That's not my issue over here. The bottom, the left bottom is bigger than the right bottom, so I got this relationship over here. So what I could do over here is I could say, well, this simplifies to the natural log of n over n squared. So I'm going to say over here that this will be less than the sum, n equals 2 to infinity, of the natural log of n over n squared. All right? So I got that covered, and my issue right now is like, what do I do with that guy over there? And there's certainly a lot of things you could do, but what I'm going to do is, it looks like I could do this by integration. All right? So what I'm going to claim over here is, I'm going to write this down for you. I'm going to write down f of x is equal to the natural log of x over x squared. All right, and certainly x squared overpowers the natural log of x. So I'm going to say this is continuous, it's positive, and it's decreasing on the interval from 2, I'm starting at 2, by the way, to infinity. All right, if you want to play it safer, you could say, well, I'll take a bigger number, like 1,000 to infinity. It doesn't really much matter, because we'll have the finite sum in the beginning. But 2 to infinity looks pretty reasonable. So let's see if we can do the integration. And what's the integration going to look like? It's going to look like 2 to infinity. We're using the integral test, by the way. Again, if it's tough to integrate, I'm going to have to backtrack and do something different, by the way. Probably a linear comparison test or something. So let's take a look at that. And I'm going to say, let's see, 2 to infinity. And this would be the natural log of x over x squared, and then dx. All right, I got troubles right now, and the troubles is, can I integrate that? So I'll put this on the side, and I'm going to write ln x down, x squared dx, and I'm going to try to do it by parts. So I'm going to say u equals the natural log of x, and du would equal 1 over x dx. And then I'm going to say the dv would be x to the minus 2 dx. That means v, let's see, I'm integrating now, right? So x to the minus 1, and I got to divide by minus 1. So that's not so bad. So I think I can do that. What do you get over here? You're going to get minus, I'm going to be careful here. So it's going to be, let's see, ln x over x minus, let's see what you get over there. It's going to be, let's see, it's going to be, let's see, I got the dv, now it's going to be du, so 1 over x times, well, it's going to be plus now, so it's going to be 1 over x squared dx. All right, let me see if I can do that now. So you get minus the natural log of x over x. This is going to be, it's x to the minus 2. I think we just did that, right? And what would that give me? That would give me, let's see, minus 1 over x. And then some constant of integration, by the way. So I think I'm ready to put the limit down now. So let's write this over here. There's going to be a limit as a goes to infinity. And let me write the antiderivative down now. So what's going to be minus the natural log of x over x minus 1 over x. Limits of integration are going to go from 2 to infinity. Well, I'm sorry, I keep doing that. I have to erase that. It's not true. This infinity is not infinity, it's just the finite number a. Then I'll do the limit. So I'm looking at this thing, and I think I can do the limit now. And let me put this over here. As a goes to infinity, I look at both of those terms, and x overpowers natural log very quickly, by the way. So I'm going to say you get a 0 initially, and then you get minus a minus, so it's going to be plus. Let's write this over here. Plus the natural log of 2 over 2 plus 1/2. What does this give us? 2, 1 plus the natural log of 2. So what do I know? I know the series that we just were given over here is certainly convergent, right? It's convergent. Whoops, sorry about that. Convergent. How do I do that? By the integral test, all right? I also want to point out, certainly you could also do a comparison test, all right? And someone says, why would I do that? I don't know, maybe it might be easy to do by comparison test or limit comparison test. I just thought the integral test was kind of a convenient way to go about that. But don't think that you can't try other ways to do problems, all right? I did it by integral test. We found its convergence, okay? Thank you.